When astronauts travel to Mars, they will face an unseen threat: radiation. Beyond the protective magnetic field of Earth, galactic cosmic radiation and solar energetic particles can cause permanent harm to humans. Too much space radiation can trigger radiation sickness, and over time it can damage DNA and even cause cancer. On a trip to Mars, which takes 6 months each way, a crew could receive 60% of their career-long radiation exposure limit. Astronauts on Mars may wait up to 500 days for a return journey, accumulating more radiation, for a total of nearly 1 sievert for the entire trip. Although the type of radiation is different, 1 sievert of space radiation is approximately equivalent to receiving 3,000 chest X-rays. To make space travel safer, we need something faster and more efficient than chemical rockets. One potential solution is to use ion engines. These do not have as much thrust as rockets, but they allow continuous acceleration, which would shorten the journey. With a grant from the National Science Foundation, Tibbar Plasma Technologies is currently developing a fusion device which could potentially be used for propulsion in spacecraft. The device would use safer fuels, such as proton-boron 11, which releases helium-4 alpha particles during fusion instead of neutrons. These alpha particles can be collected and converted into electrical current, with a direct energy converter providing electricity for the spacecraft. At the other end of the chamber, an ion engine would propel the spacecraft.
This is the experiment that we're working on for the National Science Foundation. We call the device the Shiner device. It works as a plasma heat engine. And what that amounts to is that it compresses and expands plasmas, and it's a cyclical process, and it doesn't dissipate energy in the process of doing that. That's the basic idea behind it, and that's the way that we can get energies that are thermonuclear for very short periods of time, from which we can get the fusion out of it.
How is the project going?
It's going pretty well. The project is ambitious for phase 1 in that we both have to design the machine, build it, and get it to operate. And right now the designing and the building are completed, and we are in the operational phase trying to make it work.
What have you learned?
Well, we've learned that it's been kind of difficult to make the plasma that we're trying to do. And it takes more power than we thought it would initially take. So that's one of the things that we're going to have to be able to straighten out before we can proceed to the phase 2 part of the program.
What is aneutronic fusion?
Aneutronic fusion in our case uses boron 11 and a proton, and it gives 3 helium atoms off of it, which means that there are no neutrons coming out of the system. It's better simply because the major issue you have is how much dosage people are going to get on the travel, and what you don't want to do is to have a lot of dosage from being up there too long, which is what happens with conventional rockets, or you've got a lot of radiation if you use fission-based nuclear rockets. So it gets around both of those problems.
Could the device be used as a power source on Mars?
Yeah, it could, and it would be a very effective one. I mean, we're looking at things that are small and compact, so you don't have a lot of material that you'd have to put up there, and that would be a major advantage. So yes, it could be used on that.
What are your future plans?
Well, the plan right now is to finish up this phase 1 that we've got with the National Science Foundation, and we'll see how that goes. And if we get some favorable results, we'll ask for a phase 2, which is considerably more funding. And the goal of the phase 2 is going to be to really demonstrate that we can make significant amounts of fusion with this machine.
The challenge of going to Mars will require innovative technology. Although we still have a long way to go, with hard work and creative solutions, we hope to one day achieve the dream of becoming a spacefaring civilization.